how many of you have tried displaying on OLED? Is there anyone hasn't tried display anything on OLED? So for OLED display, I only have one thing to emphasize is OLED, this is the screen, okay, and as I said, there are 4 pixels. You can consider like them as the LEDs. Okay, so for each of them, it's either on or off. That's all. Okay, so if it's on, it's white color. If it's off, it appears black. That's why on the screen you can only see 2 colors. Okay, and then the thing I want to emphasize here is, if you don't purposely clear it, if you don't purposely clear the text here, it will appear all the time. Okay, for example, sorry. So for example, if I display something like, okay, this is my screen. I display X value, right? We display Y value, we display Z value, right? For the accelerometer, that's it. For the first run, your X equals to 1, 2, 4. I don't know, any arbitrary number. Your Y equal to 51, your Z equal to 23, that's it, like this, okay? And then you are going to refresh the window when you get the new data, right? Let's say for the next one, your X become, let's say, 31, okay? And your Y, let's say, is 56, your Z equals to, let's say, 2. Okay, that's it for the next one. This new data you want to display here. But if you don't clear it properly, you don't clear this window properly, what will you see is you will see something like this. You get what I mean? Means your data becomes shorter, but whatever you leave here, that's actually from your previous reading. Okay? If you don't clear it, it will be stay there forever. Okay? So that's how it works. So that's why sometimes if people didn't do the, all these residues carefully, you will see some funny numbers. For example, 314 is not a valid value for X. Okay? So you need to think about a way to clear this one. Okay? So clear this one. Remember how we display things on OLED is? Okay, let's say for display the ACC, basically you have the ACC read function. From here, you can get your X, Y, and Z value, right? And then you basically use as print f, let's say string, and then you have X percentage D, Y percentage D, Z percentage D, and you have your X, Y, Z value. So you use this one to basically load your numbers into one of the string. And then next one is you do OLED display. I forgot the name of the function, but this is the meaning of that. You display your OLED by displaying this string, right? And you have the coordinate value. You have the start of the screen. You have the background color. You have the text color, something like that. You are using this function so that you get this kind of output, right? So you see, to get rid of this residue, what you could do is you can actually add space after that. Let's say I'm dealing with only X. Okay, so here you have percentage X, percentage D, and then you have this one, and then here you are displaying the X value only. You don't want to get this Okay, so the way you write in this one will be, normally it will be percentage D and X like this, right? But to prevent this, what you could do is you can actually leave space behind that. Means you have percentage D, like space, and then you have something like that. Okay? So you see, every time for the first value, let's say 104, you are displaying 104, actually space. That's it, there's three space after that. And then new data coming in is 31, right? So it will become 31 space. So you see, you clear this location. Okay? So that's how you you display the correct number. Okay? And while you are doing this, okay, you better use your console to display the real XYZ value. Okay? Because people try to display on this and try to read the XYZ value from here. What I'm saying is, what if the number here doesn't make any sense, like the previous case 131, and you have 4 as a residue over there? You try to understand how come my X value is 314? It's not a valid value at all. Okay? So this is not a good place to understand accelerometer. Okay? Because you made a mistake on the OLED. Okay? So that is the first thing I will say. The next is about the accelerometer. So what's the actual meaning of the accelerometer's reading? Did you try to see the values of accelerometer's output? X, Y, and D. Did you see the values? What's the values you got? What kind of values you got? Did you try to find out the range? What is the maximum number of this guy? What is the maximum number?
15.
What's the maximum number of this one? And why? And if you got the value, let's say it's 31, what's the meaning of this one? What's the unit of this number? There are so many questions. Okay? What's actually accelerometer does? What's the meaning? What's the function of the accelerometer? What's the meaning of accelerometer? What does this sensor do? Come on. Do you have an accelerometer in, do you think there's an accelerometer in the Apple Watch?
Yeah.
Right? Do you think there's an accelerometer in the computer? Maybe not, right? Then what's the function of the accelerometer? Why your Apple Watch or your other sports, brand needs the accelerometer? Sorry? Measure movement. How does it measure movement? Let's say these are the values you basically directly outputted from accelerometer. What are we sensing? This is a sensor, right? What are we sensing? Your light sensor is sensing the light intensity. The temperature sensor is sensing the temperature. What does accelerometer sensing? Sorry? Location.
Yeah.
No location. Location is the one you are saying is the GPS. Accelerometer? Come on. You can get the movement information by analyzing the output of accelerometer. But you are not measuring movement directly. Okay? Just like a temperature sensor, you are measuring temperature directly. And then it can tell whether now it's summer or winter or spring, or it can tell you the season. But you cannot say accelerometer is sensing the seasons. No. Okay, same thing here. Your accelerometer can tell you the information about the movement, but what is actually sensing? Yes, acceleration. Or another word, gravity. Okay, you are standing here. Where's the gravity? What direction? You take the same thing, you put it on the earth and you put it on the moon. You weigh them, the weight will be different, right? Why is different? Because of the gravity. Because of the G, right? So this is actually the parameter your accelerometer is sensing. Gravity. Okay? So imagine you have your board. Here's your board. You have an accelerometer here. Okay? Why you have 3 directions? 3 dimensions because you are basically measuring the three dimensions gravity. You want let's say if here is x, here is y, here is z. Basically, your accelerometer is sensing how much gravity on x-axis, how much gravity on y-axis, how much gravity on z-axis. Okay? That's simply what does this guy do. Okay? If you don't understand this, there's no way to continue. Okay? And once you understood that, let's say I put my board on the table completely flat. Okay, imagine it's perfectly flat on my table. Where is gravity now? What direction is your gravity now?
C.
Which direction? There's a person standing here. Where is the gravity? Downwards. Same thing here. Where is gravity? Downwards. What will be the value? Gravity value here? You are standing here. What is your weight? How to calculate your weight? mg. m1g. Okay, m is your mass. Okay, a fatter guy coming stand here is also mg, m2 maybe. But can you see that they are experiencing the same gravity, g? Okay, so g is gravity, m is not gravity. Okay, m is another parameter. Okay, different people get different m, but you will get same g. So here's your g. So if your board is like this, what will you see on here? What will you get on your x? 0. What will you get on your y? What will you get on your z? In g. In g. What will you get?
G.
Minus g. Okay? And then, let's say, now the bar is like this. Now I tilt it 90 degrees, like this. What do you get? If I put it this way, here is your gravity, right? So here is your z. Can you see that? You flip it, and then what else? You have this one. This is z, this is x, this is y. Then in this case, what will be your value? X value? G, positive G, because G is the same direction as positive X. G, X value,
0.
what Z value?
0.
0. I mean, I'm talking about perfect case, okay? Then, arbitrary case. Let's say my board is neither like that nor like this. My board is tilting, arbitrary angle. I don't know how to draw. My drawing is very poor, but let's say this is the way. It's like standing like this, okay? Arbitrary shape, any shape can, okay? So you have a G, and for your board, you still need to figure out where is X, where is Y, and Z, okay? For your board, X, Y, and Z not change, doesn't change at all. Okay, that's the direction. That's the direction regarding to the accelerometer. Once you solder your accelerometer onto this, X, Y, Z already fixed. Okay, so you have a G that like that. Then you can see that in this case, you will get values on all these three coordinates. Right? These three, none of them are zeros, because your G are actually going to be like separate to three different directions. But there are still relationships over there, right? That's okay. This explains how accelerometer works. When your things is static, okay, then to detect the movement, you may need some physics knowledge. Okay, just as I said, when you are standing here without moving, you are experiencing G. But what I'm saying, if you are running with a constant speed, or if you are running with accelerating speed, or if you are, all these are related to physics, right? About A now, right? Acceleration. Okay, so the way to detect the movement, okay, of course there are many ways to detect the movement. You can use a very simple one. Let's say if X change, I assume it's already moved. I mean, you can do that, simplest way, but not accurate. That's why, different brand of your sports band, they detect, your steps differently, right? Why you pay $1,000 for your Apple Watch, but you pay $0 for the one who are giving free for you in the campus, right? They are different. Okay, they all have accelerometer, but the mathematics behind it is different. Same thing here. Okay, the accelerometer, you're all using the same accelerometer. Now we will see how each of the group figure out your own way to detect the movement. Okay, and why you want to do that. Okay, and whether it's accurate or not, right? So that's the thing you want to know. Also, remember the question I just asked. What's the XYZ's maximum value? Okay, and how the numbers are related to your G. Okay, those are the things you need to figure out by reading the accelerometer's data sheet. Okay, that's all I want to add on for assignment 2. Okay?